Let us look at an important technicality of C++, that is functions. So why we need function? Because we want a program to be in manageable pieces, and so that we can apply divide and conquer strategy. Then also, how can we manage our understanding to the problem domain? Function also makes the program quite easier to read, and function can be useful in many places in a program, just not at one place, but many places. You can easily test, you can distribute the labor, and the maintenance is also very easy if you are using and you understood the favorability of your functions. Try to keep your functions small, easier to understand, specify, and debug. The general form of the functions are like this. You have return type, the name of the function, and then you have formal arguments. Arguments, parameters, all these are same. You can also have with this declaration a definition also. Hope you got the idea of definition and declaration. This is the name of the function, the return type, then these are the formal arguments, and then the body. Just for example, we have a function called f. The argument, that is the formal arguments, are a and d. One is of integer type, the other is of double type, and the return type will be double, and the return will be a into d, and once a will be multiplied by d, since double is higher, that integer will be first converted to double, and then the result will be thrown, or result will be returned. So how we get this double? This is the explanation. And formal arguments, these are called as parameters sometimes. Even if you don't want to return a value from the function, there is an option called void. Void means doesn't return a value. A body is a block or a try-catch block. So you can have these are the braces. Inside is you can have your code. Also you can have a code inside your try, and then the catch. If some exception is there, this will be thrown. You can do the mitigation work here. Function represent implement computations and calculation. So this is the utility of your functions. Then there are various type in which the functions may be seen. First is call by value. What is by call by value? It sends the function a copy of the argument value. Means this a, it will get the value as a copy, not the actual value itself, right? For example, in this case we have xx as 0, and if we call this function fxs, and what is f function defined? A is equal to a plus 1, means it will increase a value and will return an a. Here what will happen? This function will be called, and what we are passing is 0. 0 will be passed, 0 will go here, and it will be incremented, and the result will be 1. But if you print this xx value, you might think that since we have passed this xx inside this function, it should be some xx plus 1. That is, it should be say xx plus 1, 0 plus 1, that is 1. But it is not going to do that. It will print 0 only, because this function does not change this x. Since this xx will only send a copy, that is xx will make itself or make a copy of itself, and this copy will be called as a here, and a will be incremented, not xx. Let us take another case. If you have yy value as 7 and you are passing yy 7, you will be tempted to know what will be the result. It will be quite easy that if you use this function, the answer will be 8. No trouble with this. But once you print this yy, the value will only be 7, because the yy is actual not passed. So there will be no change inside this function for this yy or xx. because we have sent a copy of YY, a photocopy of YY is now called as A, and now A will be changed, not YY. So YY will retain its value. But there is another sequence or another view of function, how it may be called. This is called by reference. The call by reference, it passes a reference to the argument, and in this what we are passing is int, similar to the value int A, but in front of A we are using, or we are passing, or we are declaring ampersand. And by now, the discussion we have done till now, you might recall this ampersand is nothing but it extracts or it gives the address of the variable. So what we are trying to do is, we are trying to do something on the address or the memory location. Let's see, we are passing x equal to 0, fx. X is going to print 1. This we have already seen in the previous discussion. But when we print x, unlike what was printed here as 0, you will see that xx will be printing value as 1. So actual xs will be passed, actual xx will be passed to A, and A will be the xx only, and this value, whatever is changed, this value will be given back. Means if I pass 7 is going to change to 8, but when I print the 7 it will be 8. Now see xx, this is xx, it contains a value 0. Now I am not sending this xx a copy, which I was doing in the call by value. I am not sending this copy, I am actually sending the reference of this. Means this is the address, ampersand of xx will return me the address. So I am passing the address of this xx location. Now when inside function, the action will be taken on this value only, so 0 will become 1, and as 0 will become 1, when we print xx it will be printed as 1. Then functions avoid non-constant reference arguments. When you can, these things you can do, means they can lead to obscure bugs when you forget which arguments can be changed. That is, in this particular case you have some function called increment and you return a plus 1. In this case you have increment 2, and what you are doing is you are trying to pass the ampersand. Means this is called by reference kind of thing. So plus a. For x equal to 7, when you call this increment, it will be passing a value, and since this is a call by value, it will give you a value as the value which is required. But while doing this, this is somewhat buggy. So why have reference argument? They are essential for changing several values. What I am trying to suggest is, try not to do this very often. Seldom it is okay. And if you want to manipulate the containers, that is vector, then you need to have this kind of functions. But constant reference arguments are also often very useful. Call by value, by reference, and constant reference. What is this? You have a function called f, you have a value a, then this int ampersand r, then you have const, means you are making it constant, and then int ampersand cr. You are making a constant integer and then ampersand cr. What you are doing is, this cr is constant, this you have made as constant, and now you are trying to increment cr, which is not possible. You have already made it constant. Constant value cannot be changed. But in this particular case, you have a and r and const int ampersand cr, and once a, this is fine, no problem, a can be incremented, r can also be incremented. What about this cr? Cr cannot be incremented. So what you can do is, you can do you can pass CR to some or the other value like int x. Now you can increment x. So this is a two-step procedure, but you can never ever change a constant value. Let us see a function. These const references are very useful for passing large objects. X, Y, Z all 0. You are passing a function g in this. This is a function g, and you have passed 0, 1 and 0, 0, 1 and 0. So once you call this function 0, 1, 0, the error will be the reference argument r needs a variable to refer to, right? What this means is you are passing a constant value, but you have already defined that this is a reference value. So it actually, this r will always require, this argument r will always require a variable to refer to. A variable, you are passing 2. So just change this 2 to some variable. And in this case, you are passing 3. No problem with that, because actually this CR which you have used here is constant. We can pass a temporary. No problem with that, right? So these constant references, as I suggested, are useful for passing large objects. References or reference is a general concept. This is not just for call by reference, but for example, if we see int I equal to 7, and if this is a statement known as int %r equal to I. So what it is going to do is, when you put r equal to 9, automatically I will become 9 as well. Why? Because I is referring to r. When you make r equal to 9, I will also become 9. If you make it constant, const, and if you want to change cr equal to 7, the problem is that cr, it refers to a constant, but if you place I equal to 8, cr, this will write out the value of I, because cr is pointing to a constant value I, and if you place I equal to 8, this is going to give you this 8 only. So you can think of a reference as an alternative name of an object, and you can't modify an object through a constant reference. This is the trouble here, and you can't make a reference refer to another object after initialization. For example, this is range for loop. For loop means you have a string from S, and this string S is a copy of some value Vi. When you print it, no problem with that, S will print. But when you do something like this, that means you are giving a reference, then this will be no copy, because this is a reference, you want to print S. And for this particular case, this is string %s and v, but this is constant, so we can't modify v. Okay, s is a copy of some vi, this is going to copy this, there will be no copy, and we don't modify v. An important aspect which was introduced in C++ 11 was const expr, const expression. So you can define functions that can be evaluated at compile time using this const expression function. For example, let us have a xscale double variable as 10, then you have a yscale double as 0.8, and you can have say a function scale whose input is point p and whose output is also point, but remember that this is a const expr, so it will be only evaluated at compile time. This will fix it to compile time. What this function does is it will return this xscale into some p dot x value and yscale into some p dot y value. So two values px and py will be multiplied by the corresponding scales. If we evaluate at compile time, like scale and pass some value 1, 2, 3 or 4, 5, 6. This will be actually 123 will be px, p dot x, or 4, 5, 6 will be p dot y, and they will be multiplied by 10 and 0.8, and the result will be stored in point x, this variable. But if you want to, or if you wish to use it at runtime like this, you are passing a point p at runtime, because this will be only possible at runtime. And when you are going to call this will be an error, because this is, you want it to be compile time evaluation only, and you have requested for variable argument. This is not possible, but this is possible. You can just pass p, this pass p with scale and copy it to x2. There will be no problem, because it is runtime evaluation. Now, guidance for passing variables: you can use call by value for very small objects, call by constant reference for large objects, and call by reference only when you have to return a result rather than modify an object through a reference argument. So const reference is specifically for large objects. Let us take some example. Class image. These are quite huge objects. So when you do something like this, if image, you are trying to pass image as value, this is going to be very slow. And when you are trying to do this %i, there will be no copy, but this f function can modify my image. And in this particular case, const image %, you should not do this, because there will be, as Strauss suggested, this won't mess with my image. And image, make image, this is most likely this super fast, right? We'll see about this later. And then namespaces, that is, consider this code from two programmers, say Jack and Jill. This is in Jack's header file, jack.h. This is also in jack.h, glob and widget. And in this function is in Jill's header file, jill.h, and in this class widget, this is also in jill.h. So this is, in your code you have included .h of Jack and Jill. Now when you try this function with widget p, there will be error, means multiple definition of widget. This .h also had widget, this .h also has the same name widget. How you are going to resolve this? For that you have a rescue which is known as namespaces. So the compiler will not compile multiple definitions. Such clashes can occur from multiple headers, and one way to prevent this is using namespace. So let us have a namespace called Jack. Inside it you can give this, and this, let it be in jack.h, and you can also call jill.h, same way. But when you are calling this Jack, or you are trying to use widget p, you can just use Jack : widget p. Why? Because Jack widget class will not clash with a different widget. You are specifying that I have a namespace Jack, this Jack, and I want to use this widget of this Jack. So we'll be using this widget of this Jack. So a namespace is actually, in Java we call them packages. It's kind of package in which you put your things. So it's a name scope. It is a name scope. And this double colon syntax is used to specify which namespace you are using and which objects of the same name you are referring to. For example, cout is the namespace under std. So you have to use using name std, and you would write std : cout. Please enter my stuff. Using declarations and directives, as I just suggested, you have to use this cout. You have to always do std : because std is the namespace of cout. As cout is inside this std namespace. So you can use this using declaration directives to avoid this always writing stuff. You have to keep on writing. There will be some rescue to this. You could write a using declaration using std cout. When I say cout, I mean std double colon cout, and cout will be no problem. Cin will be an error because it is not in scope. What you have to do, you have to do std double colon cin. Cin and cout both are in std. Or you could write a using directive in the beginning, make all names from namespaces std available using namespace std. As I just suggested, you have to use this using using namespace std, and then you can easily use cout and cin without even bothering about the std again. So this was about functions, call by value, call by reference, and namespaces. Thank you so much. Take care.